Good morning. Today we will see about overlap add method. We have two methods. One is overlap add method and another one is overlap save method. This is overlap add method. This is the question. Find the output y of n of a filter whose impulse response is h of n, which is equal to 1, 1, 1. And the input signal x of n is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Using overlap add method. So what we have to do is they have given x of n and h of n. Now we have to solve this by using this overlap add method. Now let us solve. This is overlap add method. So what is given is x of n is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what is given is h of n is equal to 1, 1, 1. So these are the given in the question. This is the given thing in the question. Now what we have to do? We have to find this y of n. So what are the steps we have to follow here? So let us take the length of this impulse response. That is, this is impulse response. So length of impulse response. So this impulse response. So that is m. And the next one is, here we have a sequence. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This sequence should be divided into blocks of data sites having length L. We can take that as L. Now, how can we split this? So we can split into 3, 3, 3. We have to divide this into 3, 3, 3. So how much it is possible? We can split this into 3. So here we have m, that is h of n is equal to m. So we know that m is equal to 3. So after taking this, what we have to do is, we have to add m minus 1 zeros. We have to add m minus 1 zeros to this sequence, that is to this divided data. So let us take, what is here m? M is 3 minus 1 is equal to 2. So we have to add 2 zeros to the divided data. So how we are going to divide? Let us take x1 of n is equal to 1, 2, 3. That is 1, 2, 3. And finally we have to add the number of zeros, that is m minus 1. And this m represents this that is length of the impulse response. Here h of n is m. Here we have 3 data, that is 1, 1, 1. We have only 3 elements, 1, 1, 1. So m minus 1 will become 3 minus 1, 2. So we have to add 2 zeros with this in the last. Next, x2 of n is equal to, we have 4, 5, 6. First step is we have to split this into small sequences. We have to split this into small elements. So we have split it as 3, 3, 3, 3. Then the next one is, what we have to do is, we have to add m minus 1 zeros. Now what is this m? M is impulse response, that is h of n. So how many data are there? We have 3 data, 3 elements. So 3 minus 1 will be 2. So we have to add 2 zeros in the last. Then what is x2 of n? So that will be 4, 5, 6, 0, 0, because we have to add 2 zeros. Then what is x3 of n? So x3 of n, which is equal to 7, 8, 9. 7, 8, 9, 0, 0. What is x4 of n? x4 of n, which is equal to, what is x4 of n? 10. We have only 10. So we have to add 4 zeros so that we can make this equal to this elements. That is x of 1, we have 5 elements. Here we have 5, 5. So here we have only 1. In order to make this equal to this, so we are adding this 5 zeros here. Now what is h of n? So h of n is equal to, here we have 1, 1, 1. So in order to make this equal, you are adding this 2 zeros. This is the steps. Then what is the next step? We have to perform the circular convolution for this x of n and h of n. So how can we make the circular convolution? See here, that is, we have to perform, it is not visible, circular convolution. So how can we perform this circular convolution? That is, y of n which is equal to x of n circular convolution h of n. So this is how we have to perform the circular convolution. Now what is this x of n? That is, here we have x1 of n, x2 of n, x3 of n, x4 of n. So we will get y1, y2, y3 of n, y4 of n. Now what is y1 of n? So y1 of n which is equal to this x1 of n circular convoluted with this h of n. Now what is this x1 of n? x1 of n, just now we found this as 1, 2, 3, 0, 0. So we have this 1, 2, 3, 0, 0. This is circular convoluted with h of n. What is that h of n? So we know that h of n is equal to 1, 1, 1, 0, 0. So let us write 1, 1, 1, 0, 0. Now how can we perform circular convolution? What we have to do is write the last value as the first value. Write this last value of the first value as the first value and take this down. So this one will come here, this one will come here, this one will come here, and this 0 will come here. Then again perform the circular convolution. This 0 will go to the top. And now take this down, 0, 1, 1, 1. Again take this 1 to top. Now this 0 will come down, 0, 1, 1. Now take this 1 again here. So 1, then 1, 0, 0, 1. Again if you take this 1 here, what happens? This will get repeated. That is 1, 1, 1, 0, 0. So let us stop here. Now what we have to do? That is general matrix multiplication. We know how to do matrix multiplication. So which is equal to, so we can write this as 1 plus 0 plus 0 plus 0 plus 0. Then for 2 it is, for second column, that is 1 plus 2 plus 0 plus 0 plus 0. Then third one it is again 1 plus 2 plus 3 plus 0 plus 0. Then the next one is 0 plus 2 plus 3 plus 0 plus 0. Then the last one is 0 plus 0 plus 3 plus 0 plus 0. So what is the answer for this? Which is equal to, you can write this as 1, 3, 6, 5, 3. So the answer for this is 1, 3, 6, 5, 3. That is y1 of n is equal to 1, 3, 6, 5, 3. Then next one is y2 of n. Now we have to find y2 of n. What is y2 of n? Again it is y2 of n will be equal to x2 of n circular convoluted with h of n. So what is x2 of n? So x2 of n we have written 4, 5, 6, 0, 0. So here we have to write that 4, 5, 6, 0, 0 into this h of n. So already we have written here, that is 1, 0, 0, 1, 1. Then 1, 1, 0, 0, 1. Then 1, 1, 0, 0. Then 0, 1, 1, 1, 0. Then here it is 0, 0, 1, 1, 1. So after circular convoluting, that is after multiplication, we will get here 4, because only 1, 1 here, remaining will be 0. Then here we have 4 plus 5, so that is 9. And here it is 4 plus 5 plus 6, so 10, 15. And here it is 0, here we have 5 plus 6, it is 11. Then here we have only 6. This is our y2 of n will be equal to 4, 9, 15, 11, 6. Now what is y3 of n? y3 of n will be equal to x3 of n, the circular convoluted with h3 of n. Therefore y2 of n is equal to, what is x3 of n? Here we have 7, 8, 9, 0, 0. So here it is 7, 8, 9, 0, 0. And it is matrix multiplied with this 1, 0, 0, 1, 1, 1, 0, 0, 1, 1, 1, 0, 0, 0, 1, 1, 0, 0, 0, 1, 1. Now add this, here we have only 7. Then here it is 7 plus 8, 15. Here it is 7, 8, 9, 17, 24. Then here it is 8 plus 9, that is 17, and here it is only 9. So this is 7, 15, 24, 17, 9. So this is our y3 of n will be equal to 7, 15, 24, 17, 9. Now what is y4 of n? Now it is y4 of n will be, which is equal to x4 of n circular convoluted with h of n. Now what is y4 of n? Here we have 10, 0, 0, 0. The remaining will be 0, 0, 0, 0. And now we know it is h of n, that is 1, 1, 1, 0, 0. Then 0, 1, 1, 0. 0, 0, 1, 1. 1, 0, 0, 1, 1, 1, 0, 0, 1. Now what is this? y4 of n. So y4 of n will be equal to, here we have 10, and here we have 10, 10, then 0, 0. So this is our y4 of n. Therefore y4 of n, which is equal to 10, 10, 10, 0, 0. So we have found this y1 of n. This is our y1 of n. This is our y2 of n. This is our y3 of n, and this is our y4 of n. Now what we have to do is, we have to write this in order to find the final convolution, that is y1 of n, final answer of y of n. So how can we write that? That is y1 of n is equal to, what is the answer for y1 of n? y1 of n is equal to, here we have 1, 3, 6, 5, 3. y2 of n is equal to, now what we have to do is, we have added last two zeros, isn't it? So finally we have added last two zeros here. Since we have added last two zeros, what happens? We have to start the numbers from here, because this is called as overflow, because it has overflowed, isn't it? This is the original number, these two are overflowed here. So what we have to do? We have to start the numbers from here. So what is y2 of n? That is y2 of n will be equal to, here we have 4. So this is the last two numbers. Why we have to add this from this last two numbers? Because this is overflowed. These two are the numbers, and the last two we have added zeros. So where we have added zeros, we have to start from there. So 4, then y2 of n is 4. Already we found that. 9, 15, 11, 6. Now what is y3 of n? In the same way, y3 of n, we have to add from the, we have to write from the last two, because these two are overflow. So what is y3 of n? So y3 of n is equal to, here we have 7, that is 7, 15, 24, 17, 9. Now what is y4 of n? y4 of n is equal to, so again we have to start from here. So what is y4 of n? So already we have written y4 of n, 10, 10, 10, 0, 0. So we have to write here, that is 10, 10, 10, 0, 0. Now what we have to do is, we have to add this, that is, here we have 1, here it is 3, and here it is, see here, it is 1, 3, then 6. Now what we have to do is, it is overlap add. So add this two. 5 plus 4 is 9. 9 plus 3 is 12. And here we have 15. 11 plus 7, 18. Here it is 21. It is 24. Here it is 27. Here it is 19, 10, 0, 0. Now this is the final answer, that is 1, 3, 6, 9, 12, 15, 18, 21, 24, 27, 19, 10, and so on. So final answer y of n, which is equal to, we have to write the answer like this, which is equal to 1, 3, 6, 9, 12, 15, 18, 21, 24, 27, 19, 10, because these two are overflow. So omit this two. So we have this as the answer. Now how could we know that this is the correct answer? We can cross check this. How can we cross check this? Just I will say you. Listen, what is the question here? What is the question? That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So write that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have up to 10 here. This is the question. So this is the sequence which is given in the question. And what is our h of n? So what is our h of n? H of n is equal to 1, 1, 1. So write that 1, 1, 1 here. Now what we have to do is just multiply this. 1 into 1 will be 1. Here it is 2, 3, 4, 5. Multiply this. 1 1s are, 1 2s are, 1 3s are, 1 4, 1 5, 1 6, 1 7, 1 8, 1 9, 1 10. Likewise, we have to multiply this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, multiply this 1, 2 because this is our h of n and this is our x of n. So, we are going to multiply this 3, 4, 5, 6, 7, 8, 9, 10. So, after multiplying this, what we have to do is just cut this diagonally. 1, 1, 2, 1, 2, 3, 5, 3, 4, 5, 4, 5, 6, 5, 6, 7, 6, 7, 8, 7, 8, 9, 8, 9, 10, 9, 10. So after doing this, what we have to do is just add these numbers and write here. What we have to do is just first we have only 1. Then we have 1 plus 2 here. 1 plus 2 is 3. Then 1 plus 2 plus 3, 6. Then 2 plus 3 plus 4, 9. 3 plus 4 plus 5, 9, 12. Then here it is 6 plus 10, 15. Then 13 plus 5, 18. Here it is 21. And here it is 24. Here is it is 27. Here it is 19. Then the last one is 10. Now we can cross check this. This is our y of n is equal to. Now cross check this here. That is 1, 3, 6, 9, 12, 15, 18, 21, 24, 27, 19, 10. So like this is used for verification purpose. So you can verify the answer by using this method. We can verify the answer. This is our answer which we get after this computation. But we can verify this by using this verification method. This is our first problem. Like this, we can solve the another problem, that is, see here we have find the find the output y of n of a filter whose impulse response is h of n is equal to. So we have h of n 1 minus 1 and the input signal x of n is equal to, this is the sequence, using overlap add method. So what they have given is using this overlap add method. So already we know the procedure what we have to do. Now we can straightly solve this problem. So we know m is equal, that is x of n is equal to. Now write the question 1 and you should not even miss minus, because if you miss minus then the entire answer will become wrong. Minus 3, minus 1, minus 4, 1, 4, 2. And what is our h of n? H of n is equal to 1 minus 1. So this is our h of n. Now what we have to do? We have to split this into number of sequence. So how can we split? We can split this into 2. So 2, 2, 2, 2. So after this, next step, the next step is we know h of n is m. So we have m is equal to 2. What we have to do? We have to add m minus 1 0. So we have 2 minus 1 which is equal to 1. So we have to add 1 zeros with this sequence. So what is x of 1 of n which is equal to? Here we have 1 minus 1. So 1 minus 1. After this we have to add 1 0 with this. So 1 minus 1 0. Then next x2 of n. x2 of n which is equal to, we have 2 0 add 1 0. x3 of n which is equal to minus 3 minus 1 add 1 0. x4 of n is equal to minus 4 1 add 1 0. x5 of n is equal to 4 2 add 1 0. Now what is our h of n is equal to? We have 1 minus 1, so add 1 0. So what we have did after this is we have splitted the data into small data. We have splitted the sequence into smaller elements. Then we have written that x1 of n, x2 of n. So before writing this, we have to add number of zeros. We have to append number of zeros in the end. So how can we add number of zeros? By using this m minus 1. What is this m? M is the impulse response. So m minus 1, here we have only 2 values, so we have to write here 2. So m minus 1 will be equal to 2 minus 1, so 1. So we have to add 1 zeros with all the elements. So after adding this, what we have to do? We have to perform that convolution, that is by using circular convolution. How can we perform circular convolution? That is y of n, which is equal to x of n. This is circular convoluted into h of n. Now what will be our y1 of n? So y1 of n will be equal to x1 of n circular convoluted with h of n. Now what is our y1 of x1 of n? x1 of n is equal to, that is 1 minus 1 0, that is circular convoluted with, what is our h of n? 1 minus 1 0. Now circular convolute this first. This will be 0, then here we will have minus 1, then minus 1. So this minus 1 will go up. So take this 0, take this 1. Again, if you take this 1 here, what happens? The same thing will repeat. So no need to write that. So we will have 1 minus 1 0. Take the 0 first, then you have to take this 1, then minus 1 here. Then write this minus 1 the first, then take the sequence here. Then the next one is do the matrix multiplication. So here we have 1. So 1, then this will be 0, and here it is 0. Then the next one is, here we have minus 1 into 1 is minus 1, and here we have minus 1 into 1 will be minus 1 plus 0, and here we have 0. So the everything will be 0. So here we have 0, then minus 1 into minus 1 will be plus 1, then this will be 0. Now what is the answer for this, which is equal to? So answer for this is 1. Here we have minus 2, then here we have 1, then y2 of n. So what we have to find is y2 of n, which is equal to x2 of n, which is circular convoluted with h of n. Now what is that y2 of n? So y2 of n, that is x2 of n. x2 of n we have written here, that is 2 0 0. It is circular convoluted with h of n. So here we have h of n 1 0 minus 1 minus 1 1 0 0 minus 1 1. So we will get answer as, which is equal to, here we have 2 comma, and here we have minus 2, then here we have 0. 2 minus 2 0. That's it. And what is our y3 of n? Now what we have to find is y3 of n is equal to x3 of n, which is circular convoluted with h of n. Oh, it is not visible. Okay, x3 of n. Now what is x3 of n? So here we have x3 of n is equal to minus 3 minus 1 0. That is minus 3 minus 1 0. And what is our h of n? h of n is 1 minus 1 0. So 0 1 minus 1, and minus 1 0 1. So again, if you write this one, this will be equal. So what we have to do? Multiply this. So we will get y3 of n is equal to minus 3, and here we have minus 3, that is minus into minus plus 3 minus 1. So it is equal to plus 3 minus 1. So 2 comma, here we have 0. Minus into minus will be plus 1. Minus 3 plus 2 1. This is our y3 of n. Now what is our y4 of n? So y4 of n, which is equal to x4 of n, which is circular convoluted with h of n. What is our y4 of n? Now check here, what is y4 of that is x4 of n? Minus 4 1 0. So here we have minus 4 1 0. So which is circular convoluted with this h of n, that is 1 minus 1 0 0 1 minus 1 minus 1 0 1. So which is equal to, here we have minus 1, that is minus 4 comma, and here we have plus 4 plus 1, which is equal to 5, and here we have 0 plus minus and minus minus 1, so just minus 1. Then y5 of n, y5 of n, which is equal to x5 of n in circular convoluted with h of n. What is our y5 of n? Now check this, what is y5 of n? So y5 of n, that is x5 of n is equal to 4 2 0. that is 4 to 0. Here we have 4 to 0, which is circular convoluted with 1 minus 1 0, 0 1 minus 1, and here it is minus 1, this is minus 0 1. So which is equal to, what will be the answer? So here we have 4. So 4 comma, and the next one is minus 4 plus 2. So that is minus 2 comma. Here we have 0. So here we have minus 2. So this is our answer. Now what we have to do? We have to write the final answer. Now what is y1 of n? So we have found already what is y1 of n. Y1 of n is equal to 1 minus 2 1. So let us write this. Let us write here. Y1 of n is equal to, what is y1 of n? It is equal to 1 minus 2 1. Now what is y2 of n, which is equal to, now what we have to do? We have added 1 0, isn't it? Already we have added 1 0 here. So we have to start from the last number. So what is y2 of n? So y2 of n is 2 minus 2 0. 2 minus 2 0. Now what is y3 of n? The same way we have to start from this last number. So what is y3 of n? That is minus 3 2 1. What is y4 of n? Which is equal to, start from the last number, that is minus 4 5 minus 1. What is y5 of n? Y5 of n, which is equal to 4 minus 2 minus 2. Now what we have to do? We have to add this number. So if we add this number, that is the final answer. So here we have 1 comma, here it is minus 2 comma, and here it is 3, and here it is minus 2. Now 0 plus minus 3. I'll keep the paper correctly. Okay. So here we have minus 3 minus 1 minus 2, 2 plus 1 3, and here we have minus 2, 0 plus minus 3, it is minus 3, and here we have 2 minus 4, that is minus 2. So here we have 1 5. So 1 5 is, no, I have wrongly, 1 minute, 1, here it is 2 minus 2, 1, here it is minus 2 0 3, and here we have 2, here it is plus 2, and here it is 1 minus 4 is minus 3, and here we have 5, here it is 3 minus 2 minus 2. Now what is y of n? So y of n is equal to, y of n is equal to 1 minus 2 3 minus 2 minus 3 2 minus 3 5 3, then minus 2 minus 2. Now this is the final answer. Now how can we verify? Already I said how to verify this. This is just only for verification purpose. So how can we verify this? We can verify by writing this x of n number. What is our x of n? That is, this is in the question, 1 minus 1 2 0, 1 minus 1 2 0, then minus 3 minus 1 minus 3 minus 1, then minus 4 1 4 2. Then here we have to write, this is x of n value, and here we have to write h of n. What is our h of n? H of n is equal to 1 minus 1. So write here 1 minus 1. So after this what we have to do? Multiply this and write the number. That is 1 into 1. 1 minus 1 2 0 minus 3 minus 1 minus 4 1 4 2. Then what is the next? Multiply this minus 1 with this. So this will be minus 1. Here it is plus 1. Then minus 2 0 plus 3. And here we have plus 1. Here it is plus 4. And here it is minus 1 minus 4 minus 2. Now what we have to do? Just cut this diagonally. Minus 1. 1 minus 4. 4 1 2. That's it. Now write the answer here. Now let us write the answer. First one is 1 comma minus 1. Minus 1 is minus 2. Add these numbers. And here we have 3 minus 2 minus 3. This is 2 minus 3. 5 3 minus 2 minus 2. Now this is our y of n. Cross check this. 1 minus 2 3 minus 2 minus 3 2 minus 3 5, then 3 minus 2 minus 2. So now compare this to, now our answer is correct. So this is how we have to perform this overlap add. I hope you understand this. If you have any doubt, you can ask me in comment section, and let us meet in the next video where we can solve that overlap save method. Thank you.